That's a quick revision for your exam. So over here we have a circuit that has a battery or a cell. This is a switch and that's a bulb. If we close the switch, then current will start to flow. But which current? It's the conventional current that will start to flow in the circuit, I. Alright, as for the actual electron flow, the actual electron flow goes from negative to positive. You must also know that an ammeter measures the current in amps and a voltmeter measures the voltage in V, in volts. A voltmeter is branched in parallel this way, and an ammeter should be branched in series like that. You must also know Ohm's law, which states that current and voltage are directly proportional. Means on a graph, I and V shows a line that goes through 0. It shows an ohmic conductor. That's the rule. VRI, where R is the resistance in ohms, I is the current in amps, and V is the voltage or potential difference in V. You should also know how a filament bulb lamp looks like and how a diode looks like. If two bulbs are branched in series, then we know that the current will flow from plus to minus this way. Means that no matter where you branch your ammeter, it will still give you the same reading. While in parallel, you can see that the current will split because it has more than one branch to flow through. So the current in parallel is the sum. And voltage, we always flip them. So voltage is sum for series and same for parallel. What about the resistance? If we'd like to find the combined resistance RT of two resistors branched in series, we must apply the rule R1 plus R2, and this will give you 6 ohms reading. While in parallel, it's 1 over RT equals to 1 over R1 plus 1 over R2 to find RT combined. Considering that we have the same resistors 2 and 4, you can do the direct math application and say 1 over RT is 1 over 2 plus 1 over 4, that's 3/4. And since we want to find RT, we flip them, so that's 4 over 3 ohms. So as a conclusion, resistance branched in series give you a greater value and in parallel a smaller one. Over here we want to find the reading of the ammeter and the voltmeter. For the first diagram, we have two bulbs that are identical branched in series. Since they're branched in series, I is going to be the sum. So no matter where you branch your ammeter, it's still going to give you the same reading, which is 4 amps. To find the voltage, since the bulbs are identical, then the voltage is going to be divided equally into both components. So each one will take 3 volts and 3 volts. In the second diagram, we have two bulbs that are branched in parallel, means that I is the sum, V is the same. So if the voltmeter over here is reading 6 volts, it means that no matter where you branch the voltmeter, it's still gonna give you 6 volts. Now for the current, knowing it's a parallel circuit, then I should be the sum. If 4 amps are flowing through this wire of the circuit, then 4 amps must also flow through the other one. That's because we did not reach any node yet. At this point, the node, the current is gonna now be divided equally. That's because bulbs are identical. Alright, so 2 amps by 2 amps. But if the bulbs are not identical, then we need to apply Ohm's law in order to find the current flowing in each branch. And the sum of the currents must always be equals to 4. Now this question will help you to practice Ohm's law, which states that R is equal to voltage V divided by the current I. Alright, so you can see the first diagram that the voltage is given and the current I is given. We have to apply the rule in order to find R. For the second one, we have I, the current, and we have the resistance. We just need to find voltage by saying V is R times I. In C, we have R, we have V. You can find I by dividing V over R. This question now will help you to practice the combined resistance rules. In X, we have two resistance branched in series, so you do R1 plus R2, that's 6 ohms. In Z, we have two that are branched in parallel. Don't forget that after you apply the rule, what you find is 1 over RT. So to find RT, you need to flip it. So it's 2 over 1, it's 2 ohms. Now we can solve this exam style question. So in the circuit shown, the PD across the 4 ohms resistor is 8 volts. They want us to find the current through the 4 ohms resistance. So in order to find I, we can apply Ohm's law by saying I is equal to V over R. That's because we have R, we have V. So a direct application would be 8 over 4, and that's 2 amps. For the second question, they said, find the current through the 3 ohms resistor. So if the resistor is equal to 3 ohms, what's I, the current flowing through this resistor? All right? And over here, since we have a diagram that the components are branched in series, so our main focus is going to be on this section of the table. So how can we use the idea that in series, the current is the same? Which means that since you could find that I, current flowing through the component 4 ohms, is equal to 2 amps, so anywhere in the circuit, it's still going to give you the same exact reading, which means that the current in the 3 ohms resistor is also 2 amps. All right? So we use this idea. Now, what is the PD across the 3 ohms resistor? We want to find the voltage V across the 3 ohms resistor. V is equal to, since we have R, we have I, which is 2 ohms, we can find it by multiplying R and I. So 3 into 2, that's 6 volts. Now, last question is, what's the PD applied by the battery? And so we need to use the second idea from the table, which is that V, the potential difference in a series circuit, is the sum of all the potential differences in the circuit. So since V of this component, we just calculated that it's 6, and V of this component is 8, then V provided by the battery should be the sum of both components. And so 6 plus 8, that's equals to 14 volts. In the second question, we have two resistors that are branched in parallel, and so these are the rules that we can use from the table. First question is, what is the combined resistance? So in a parallel circuit, we can combine the resistors by saying that 1 over RT is equal to 1 over R1, which is 3, plus 1 over R2, which is 6. And that's equals to half. And don't forget that 1 over RT is 1 over 2, which means that RT over 1 is equal to 2 over 1, so RT is 2 ohms. Meaning that if I can replace these two resistors by only one resistor, like that, the reading on the resistor would be 2 ohms. Okay, how will this help us? This will help us to solve the second question, which is find the potential difference across the combined resistance. So we want to know what's the voltage across the combined resistance. In other words, we want to find the voltage provided by the battery. And this can be found using Ohm's law by saying that V is equals to R into I, and R of the combined resistance is 2, I is given to us as 6, and that's then equals to 12 volts. Now, what is the potential difference across the 3 ohms resistor? Now, what we can say is that V of the battery is 12 volts. Now, we want to know what's V of the 3 ohms resistor. Applying the rules from the table, we know that V in a parallel circuit is the same. So the 3 ohms resistor will also have 12 volts. Now, what is the current across the 3 ohms resistor? Knowing that V is equal to 12 volts, R is equal to 3 ohms, we can find I by using Ohm's law and dividing V and R. So 12 divided by 3, that's 4 amps. Now, for the last question, what is the current in the 6 ohms resistor? You can notice that they did not ask us to find the voltage V, but you can use the same rule and say that V across the 6 ohms resistance which is branched in parallel with the other components, is equal to 12 volts. And so we can find I by saying that it's V over R, that's 12 over 6, and that's equal to 2 amps. Now what you can notice that 4 amps, which is running through this branch, and 2 amps that is running through this branch, if you add them up, they will give you what? They will give you 6 amps, which is running through the main branch and the battery. In the last question, we have a circuit that is branched in series. All right? So first question is, what is the combined resistance? We can find the combined resistance using the rule RT is equal to R1 plus R2. So RT is equal to 2 plus 3, and that's equals to 5 ohms. For question B, find the current that is flowing. Since the battery reading is 10 volts and the combined resistance is 5 ohms, so the I, current flowing through it, can be found using Ohm's law, V over R, that's 10 over 5, that's equals to 2 amps. Now what is the potential difference across the 2 ohms resistor? If 2 amps is flowing through both resistors, we can find V by applying Ohm's law once again, and it's R into I. It's equal to, first we're finding the 2 ohms, so 2 times 2, that's 4 volts. And for the 3 ohms resistor, that's R into I as well, 3 into 2, that's 6 volts. And what is interesting about the question is that it proves the last rule, which is V is the sum, because by adding 6 and 4, this will give you 10 volts.